Good afternoon. Okay. Do you have any information regarding off campus? Sorry, that regarding your arrival at MA232 campus? Any information that you have? Okay. Okay. Next one is Newton-Raphson method. Okay. So this method also used you can use for solving the equation. So f of x equals to 0. Okay. So what is the concept? Okay, now mathematical concept. Okay. So first that one we will discuss. Say this is the curve. Okay, let us consider this one is the curve. You have to find. Okay, you have to find the root of this curve. Okay, and what is the mathematical idea of that one? We will discuss. Okay. Say you know that the root is lies between this one. Okay. So this is y equals to f of x, the equation. This is x, this is y. Okay. So find the root. The question is find the root. Okay. Of f of x equals to 0 for this equation. Correct. So now the method name is Newton-Raphson method. Okay. Using this method, we have to find the root of this equation f of x equals to 0. Fine. So what is the mathematical concept? First, we will discuss regarding the graphical concept of the solution. So it is A0 and B0. Fine. So now you already know the concept that this is the solution. This is the x0, or this is the solution x equals to a something. We have to find. So x equals to a, if it is root, is the root. Okay. Then f of a equals to 0. That means this one. You already know this one, this concept. Okay. So now let us. You have to consider one approximation, first approximation. That is called first approximation. So let x equals to x0 is the first approximation. It is not actually. This one is not x equals to x0. Okay. That means it is not exact solution. Okay, but near to exact solution. Be the first approximation. Okay, first approximation solution. Let us. This one is the first approximation solution. Fine. So it should be okay, very close to x, very close to this one. Okay, this one. Okay. So now let us consider this one is the x0. Okay. So this one is the point x0. Now draw the perpendicular line from the point x0. Okay. To that one. What sense actually? First you have to draw the, what is that one? So this is the point x0. Okay, the first approximation solution. So this is f of x0. Okay, f of x0. So let x equals to x0 is the first approximation solution. Now you have to find another solution which is very close. Is the improved one, improved solution. Okay, x0 plus h. H is the increment that may be positive or negative. Okay, so let us consider. You have to find the x1 next solution. So this is the first solution, and this one is you have to consider. Okay, now if it is given that let the initial approximation is x equals to x0, then you know it is already given, means fine. Otherwise you have to consider. Okay, that means you have to find one x equals to x0 initial value. Okay, for this method. And now next is x1 equals to x0 plus h. So from this is x0 to improved solution is x1. And similar way, okay, x2 is x0 plus, sorry, x1 plus h, like that. Okay, x1 plus h. So this is the second approximation solution, improved solution. first case we will consider now x1. What is that one? Okay now. So now let us consider this is x0. Okay. So at that point, say this straight line parallel to y-axis, okay, crosses the curve at this point. This is, and at that point, particular point, that means x equals to x0 and y equals to f of x. This is the crossing point at that one. Okay. So at that point, you have to draw the tangent, okay, of the given curve. Okay. So now we just see, okay, what is that one? I will erase this one. Okay. So 1 minute. So now what is this point? This point is x0 comma f of x0. Fine. Draw the tangent of this curve y equals to f of x at that point, and let that tangent crosses the x-axis. Okay, at x1. Okay, so this is the new solution x1. Okay, how you are getting that x1? Now at x0 comma f of x0, comma f of x0, you have to draw a tangent of this curve y equals to f of x, and that tangent, okay, crosses the x-axis at x equals to x1. Okay, that is the new solution. So the improvement is just a red line. Okay, that is the h. This one is h. This is h. So what is the x1? The x1 is x0 plus h. That is the actually solution. Okay. Now if you do the same thing again, then what you have to do? I have to change the color. Okay. What you can do? Just again you draw the perpendicular line. That means parallel to y-axis, and let this is the parallel to y-axis line from that point. At this point, that means x1 comma f of x1. Again, you have to draw a tangent, and let that tangent touching the x-axis at this point, x2. Correct. So what is the x2? Now x2 is x1 plus new h. So if you consider this one h1, this is h2. Okay. So this one is the h2. Fine. Fine. Any doubt? So now I will remove that yellow color fold. Okay. So since you don't have any doubt, fine. Okay. This one, f of x0 comma x1 comma f of x1. Correct. I will give you some, I will give some name, okay, of that one. So this point is, this is the point, okay, it is known as a P1, okay, P1. This is a P0, okay, this is a, this point is A1 and this is A0, correct. So, fine. Now, just tell me what is tan of angle P0, A1, A0? What is the answer? Yeah, f of x0 by, you just, can you, from this figure, you can tell me the answer, I will write here then. So, tangent at the angle, for the angle P0, A1, A0. P0, A1, A0. Okay, f of x0 by h. What is f of x0? The length, correct now? Okay, what is h? Yeah, a1 a0 or a0 a1. Fine. So this is the length. Okay, so 10 p0 a1 a0 equals to this one. Fine. Okay, and this one, you know that tangent of this one is denoted by this one. What is the meaning of this one mathematically? First derivative of the function f of x. Fine. At what point? F of x. At what point? Fine. Good. Yeah, correct. X0. Correct now. So this is the tangent. So tangent, you can say p0 a1. That is a1 is the a1 p0, and this one is the tangent at the point x0. This point, at that point, this point of this one. This is the tangent. Correct now. So a1 p0. Fine. So I will write this one. Okay. So what is the answer then? What we can derive from that? So ultimately we can write this one. Small, I have to write. Okay. p0 a0 equals to, okay, a0 a1 into f dash x at x0. So I will write f dash x0. Fine. So now p0 a0, what is the distance? This distance, p0 a0, this distance, what is that one? Not x. No, a0 a1 is h. I am asking this one, p0 a0, f of x0. Fine, f of x0 equals to a0 a1. What is that one? H. Fine. Can I write this one? H equals to x0 minus x1. x0, and this is x1. Fine. So the answer is this one, f dash x0. Correct. So ultimately we can write what is the x1. Our target is to find x1, new solution, improved solution. So what is that one? Now f of x0 divided by f dash x0 equals to x0 minus x1. That implies x1 here. That implies, okay, x1 equals to, okay, x0 minus f of x0 divided by f dash x0. So what is the value of h? F of x0 by f dash x0. Fine. So this h is, if it is plus, then h equals to minus of this one. This is the change. Fine. So I will erase all this mathematical form. So finally we can write that x1 is nothing but x0 minus, okay, f of x0 divided by f dash x0. Okay, since it is iterative process, okay, it is a iterative process. You can do the same graphical concept for the next step. Okay, can you guess it? What will be the x2? What will be the x2? Fine. Since it is iterative method, iterative formula, I have already informed you this one. So same procedure, if you do the same procedure, then you can find similar way, okay now, you can find that x2 is x1 minus f of x1 divided by f dash x1. This is, so if we, okay, if we continue in the similar way, what will be the nth solution or nth root? That means nth iteration. At nth iteration, what is the working formula? This one, xn plus 1 equals to find f dash of xn. This is the working formula. Okay, na? Working formula. Okay, for NR method. Okay, so this is the graphical representation of Newton-Raphson method. Okay, surely some students have problem regarding this graphical representation. So I will next I will present the numerical or that mathematical problem. Okay, that mathematical concept, how to derive this equation. That means this working formula. Okay, the next step, just see next one. Okay, so now mathematical derivation, that one is actually graphical interpretation or graphical derivation of the Newton-Raphson formula. Okay, so now mathematical formula. Okay, let an equation f of x equals to 0 and x equals to x naught is an approximate solution of the approximation of the root alpha. So actual root is x equals to alpha. We have to reach this one by considering that x equals to x naught is the initial approximation. Is the initial approximation. Okay, that one only it is written from up to here. And before that, you have to choose or you have to find the interval of x where the root alpha actually lies. So that one you already know that what is the condition, f of a naught into f of v naught, you have to check that is less than 0. Then in between the root alpha actually belongs actually. So alpha belongs to or alpha lies in between a naught comma v naught. So that part already, this part already, it is actually this concept you have, so no problem. Now initial approximation is x equals to x naught. Fine. Now we have to improve that solution. So what is that one? How to do that one? Okay, we'll discuss. So x1, next is x1, next is x1, next x is x2 and so on. What will be the value of x0? What will, that is given, correct? That is given here. Here to improve this one. So x1 is x0 plus h from the earlier. So what is this one? Now x1, x2. So next one is you have to improve. The next value is like that, x1 plus h. So this one, this h will be different. Okay, different h. So what is that? How to find that h? Okay, so we will discuss. Now let h be the small correction on x0. Okay, so that means x equals to x0 plus h. Okay, so x0 plus h. Okay, then x1 is x0 plus h is the correct root. But we know that this one is also not a correct root, but this is a better root. Okay, now better that improved root we can say. Okay, since we are considering that this is the corrected root, so that at that point the function should satisfy the condition of equation, that is f of x1 is 0. Okay, so f of x1 is 0. So what is that one? x1 is x0 plus h, correct? x1 is x0 plus h. By Taylor series expansion we get, somebody should prompt it, what will be the answer? What is the Taylor series expansion? If you expand this one, what will be the Taylor series expansion? Quick, beta. Try to answer. I will correct it. Okay. It's not an exam. Quick. F of x0 plus h equals to 0. What is the? You have already studied. I know. First year. Okay, no. First time. Maybe before that also I don't know. But surely you have studied that one. Correct. Taylor series expansion. What is the answer? F of x0 plus plus dash or f of x0, that is sure f of x0 plus plus what? H into H times of, yeah, what is the answer? What is the next? Two or 2 factorial? Yeah. What is the next one? Fine, good. X naught. So this one, okay, equals to 0, right hand side is 0. Fine. What is the value of H? It is actually little bit improved, okay na. So H is a very small quantity, okay. So what is the, if H is very small quantity, what about the H square and H cube and so on? You have already, correct na? So H is a very small quantity. As H is small, okay. So what we can do that then? Yeah, neglecting the H square and higher. Fine. Higher. What we will get? So we will discard this part. Fine. So what is the answer? F of x naught plus h into f dash x naught equals to 0. Fine. So what is x1? So that implies f of x naught plus h into f dash x naught equals to 0. That implies, is it visible? F of x naught divided by f dash x naught. I will erase this side a little bit, okay. So initial solution is that one, we are improving that solution, fine. So this is, so I will write here, okay, what we have actually right now, h equals to minus f of x naught divided by f dash x naught. So what is therefore, x1 is x naught plus h, so that is x naught minus f of x naught divided by f dash x naught. So that one also I will write properly, here it is not visible, okay. So x1 is x naught minus, okay, f of x naught divided by f dash x naught. I will go to the previous one, geometric concept, okay na, graphical concept. Okay, what is x1? Graphically you have evaluated this one using the concept of this graph concept, graphical concept, fine. The trigonometric concept, the tan of alpha or tan of theta equals to, okay, height by base, that one, correct, this. So both x1 here and the next one, both are same, correct. So this one. So if you consider, okay, next approximation, okay, I will consider that one also, then we will stop. Let h1 be the, so what we have, initial approximation x naught, already it is improved with x1 is x naught plus h, fine. Now we have to improve this x1. So let us consider x2 is x1 plus h1, new h1, okay. So let h1 be the correction, okay, correction on x1. Then what is x2? x1 plus h1, fine, okay. And this is the corrected root, okay now. So if it is correct root, okay, if it is correct root, what is the equation? F of x2 is 0. That implies f of x1 plus h1 equals to 0. So now again okay, by Taylor series expansion, okay, by Taylor series expansion. We get, okay, f of x1 minus, okay, h into f x1 minus, okay, h square f dashed x1 and minus dot 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 equals to 0, correct? No, all are intentionally I have written, no one is there, I think so. Double dashed and so on equals to 0 plus. Again, since h is small, we can neglect, okay na? Okay, this is small, neglecting h square and higher order, okay na? Order, we get f of x1 equals to, sorry, plus h f dashed x1, h1, all are h1, okay, so equals to 0. That implies h1 equals to minus f of x1 divided by f dashed x1. So therefore the improved root x2 is x1 minus f of x1 divided by f dashed x1 and so on. I will not show anymore. So what is the x3? Now x2 minus f of x2 divided by f dashed x2. What is the f4? f4 equals to x3 minus f of x3 divided by f dashed x3 and so on. So now we will write the nth, the working formula, okay na? So the n plus 1th correction, okay, or the nth iteration, okay, what is the root? Then that nth iteration, what will be the answer? The working formula, that is known as working formula, okay na? The working formula for the Newton-Raphson method. Newton-Raphson method is, okay, this one, xn plus 1 equals to xn minus f of xn divided by f dashed xn. This is the formula, okay. So now we will consider one problem and then, okay, we will check how to use this one, this formula, okay. Next, find, should have pen and, sorry, calculator, okay. Find the root, okay, of x square minus, sorry, plus 2x minus 2 equals to 0 by NR formula, okay, by NR method, okay, correct up to 3 significant figure, okay, 3 significant figure, fine. So now solution, okay, let f of x equals to x square plus 2x minus 2, fine. Now you have to find the interval f of a naught into f of v naught less than 0, okay, that one we have to find. So let again, okay, here f of 0 equals to minus 2 sorry, and f of 1 equals to 1 plus 2, so it is 1. It is less than 0, it is greater than 0. Therefore, f of 0 into f of 1 is less than 0, okay, less than 0. Therefore, okay, want at least one root, okay, now at least one root lies between 0 and 1. Okay. So now you have to consider one approximation, first approximation, since in the problem it is not given. Okay, if it is written over here, okay, let x equals to 0.5 is the initial approximation, then you have to consider 0.5, okay, only that one as x equals to x naught, okay, but it is, you are now free to choose, okay, but if you solve it you can find the root, okay, using your calculator. You should not say the root is, original root is alpha equals to 0.5, then you should not consider x naught is 0.5, okay, at least 0.25 or something nearby, okay, or 0.75, anything, either increase or decrease, it's not a problem, okay. So now, okay, now let x equals to x naught equals to 0.6, okay, be the initial approximation, okay, of f of x, initial approximation of f of x equals to 0, okay, that is that one. Now f of x, fine, I will write in the next one. Next, here f of x equals to x square plus twice x minus 2 and f dash x equals to twice x plus 2. That one you have to do, since you in every step you have to find f of f dash x. So that is equals to twice x plus 2. That should be there. Okay. Now computational table or iteration table. Okay. Iteration table or computational table. Okay. Iteration table or computational table. What are the points for this one? It is n, next xn, next f of xn, okay, f dash xn, then hn, and now xn plus 1. Xn plus 1. So this is the table. Okay. This is the table f dash x. So now n equals to 0. Correct. What is xn? Our initial approximation x naught is 0.6. You are free to choose anything. Okay now. So now let us consider 0.6. What is f of xn? Minus 0.44. What is then f dash x, this one? Next entry 1.2 plus 2, correct? 3.2. So what is hn now? X naught plus h. What is h? F of xn divided by f dash xn. Correct? 0.1375. So what will be the xn plus 1? Xn is 0.6 minus 0.1375. Okay? 0.4625. Fine. So now xn equals to 1. Okay, so this one is, now what will be the answer? 0.4625. Now at that point, what is the f of x again? You have to find correct up to 3 significant figure. Okay. Minus 0.861. F dash xn. (2.925). What is hn? Minus 0.2. Okay. Next xn. (0.1681). I see. Okay. Next, n equals to 2. N equals to 2. What is the answer? Xn is, yeah, 0.1681. F of xn, minus 1.6355. Oh. Okay, f dash xn. (2.3362). Point. Next. Minus 0.6992. Okay. Why it is x naught plus h? I think you are, is it correct hn? 0.137? I have a doubt. What is the value of hn?
Sir, maybe it is plus n.
Huh? H1 is this one, na? Or hn?
Yes, sir. Maybe it is plus 0.137.
Okay. Oh, it's not minus, plus, correct? H is minus of f of xn divided by f of f dash xn. So I think this is minus 0.44 divided by 3.2. It is minus 0.1375. But once again minus is there. Yes. So 0.7375. Yeah. Be careful. Okay. So this one is 0.7375. This is fine. Oh, just check it. That will be changed, I think, sure. So not this one, but maybe negative something value. Just check it. 0.7375. What is the answer? At 7.7375, what is f of xn? This is f of xn. and next one is f dash xn. Zero plus or minus? Okay, plus. Okay, plus 0.0189. Fine. What is f dash xn? .475. What is then this one? It will be negative then. Minus of it will be minus of 3.54. Fine. So this one will be minus of 0.54, 0.7375 minus 0.0054. So it is 0.7354 means 21. Correct. .7375 minus 0.054. Fine, correct this one. Now, so this one is totally wrong. I will change it here. So 3, the second iteration, xn is 0.7321. What is the f of xn? One minute. 0.00. Oh, okay. That entry is there, entry book. F dash. Yeah. 4642. Fine. Now HN. HN is 0.001 divided by 3.4642. What is the answer? It will be plus only or minus, since it is minus is the formula. So 0.040 and 2. Fine. Then what is the xn? Xn plus 1? Two one two. No, 218 minus 9. This one. This one is minus. Yeah. So 0.7321 minus 402. So 8. It will be 0. So 73. I think 73201. 208. 73208. 208, I think so. 207. Okay. We can stop here. Why? As per your 4 or 3, just I will go to the previous slide. 3 significant figure. So correct up to 3 significant figure. Next. So just check 3 significant figure for the 2 successive iteration. Okay. 7.732, 732. These are the 3 significant figure. So therefore we can stop here. Okay. Since second and first iteration gives the same result, therefore the recorded solution or recorded root of the equation of the equation is x equals to 0.732. Correct up to three significant figure. Correct up to 3 significant figure. Fine. Okay. Now do homework. Okay. Next. Okay. Okay. First one for odd roll number. Okay. No need to submit. I will take one surprise test in the next class. Okay. Find a real root. Find a real root of x to the power x plus x minus 4 equals to 0 by Newton-Raphson method. Newton-Raphson method. Newton-Raphson method. Correct to 5 decimal places. 5 decimal places. Second question, second problem. Okay, now find a root, of course, real root of 3x minus cos of x minus 1 equals to 0. Okay. Okay. By NR these two are homework. Okay. Next class, in the next class, surprise test. Okay, now one problem only you have to solve. Whatever the portion we have completed till now, that is the portion. Okay. From that you have to answer only one problem. So in the next class we will conduct one test. Okay. Fine. Okay. Do you have any query? Okay. Then you can leave the meeting.
Thank you.